Hi, in this introduction video I want to explain what type of fiber network and what type of processes the solution is going to be optimized for. This is really crucial that we dive into the domain and understand the needs of the customer, because otherwise we will just create a solution, yet another solution like that's already out there. So the key thing is to really dive into the domain. Okay, so this will be the first of several videos where we're gonna kind of try to get an overview of the thing that we have to build, the requirements, and from the customer perspective. Okay, and how they work. Okay, so I will try to start to explain how the network is built in real life, and then I will also show a little how it's going to be modeled in DIS from a very high level perspective, so we get that kind of basic understanding. So I have tried to create a overview of how the network is done here in Denmark, and I think we should start with this guy here. This guy here, you can see that the typical way a fiber to the home network is rolled out here in Denmark. And in Denmark, the most used technology is something called PON, Passive Optical Network, and it's a standard. It comes in different flavors. It comes something called GPON and 10G PON, and there's something about the speed of the connections. So, and it works like we have some, of course, some internet connection. That we're talking about internet data and video, that's IPTV, and telephone, voice over IP, and that's handled by a switch in a central office. I'll get back to that. And then we have the TV signal, the old-fashioned TV signal, also known as the cable TV. That's just overlaid into the fiber signal and distributed out to the customer. And some point in the network, we're going to split that signal out using splitters, and then finally connect it to the equipment at the customer places. Okay, this drawing I can provide you too. So this is a technology that's used many places in the world, and it's a quite flexible way of creating fiber to the home network. Okay, do you have any question?
No.
Okay. So if you start from the top, like the central office where we have all the active equipment, okay? So we see this square here, the green one here. I have tried to explain in a little more detail what's inside the central office. And here you can again see we have the internet equipment that provides the internet signal. This is known as the OLT, optical line termination, and it's basically a switch. And each of these yellow things going out here is a fiber pad cable. So this is passed to a port, and one port in this switch can support actually up to 128 customers, but in Denmark we only split out to like 32 customers. So one of these fibers is actually 32 customers. You can imagine this switch can serve a lot of customers. Then we go down here. There's some other types of equipment. This is the TV equipment, and what that does is that it takes all the TV signal, all the programs, and it overlays that signal to the signal with the internet. It is done through something called a VDM, wavelength division multiplexer, that kind of combine the signal into one signal, one core. And then it goes to something we call the ODF. This is optical distribution frame. This is a rack where all the cables that's going out in the world goes into some splice patch panels, where you can patch. So you can imagine you can patch from here to the equipment here, the active equipment here. So this is how it works in the central office. Okay. And what's really important to realize here is that all this stuff here is like one point in the DS. So if you go to this over here, I've tried to show how it's going to look in the DS perspective in a map. So this central office here, now I've created some kind of symbol, but it's just one geographical object, one point in the DS. And then when you click that thing, you have to be able to navigate through all the equipment that I just showed you. Okay? So we don't draw all that equipment inside the DS. That will be some user interface that's going to show that. And there's different ways to do that, and we have some ways to do that that's quite efficient. So, okay, so remember that. So if we try to go back, and now comes the fun part, because from the central office, of course there's a lot of fiber cable going out in the world, right? But what we do in Denmark, we use something called a conduit network, a network of ducts, micro ducts. So it's pipes, right? So everything is on the ground. So what you typically do, or what you basically always do, is you have some kind of some manholes near the central office, and inside these manholes you will blow the fiber using air into some tubes or micro ducts, as it's called. They look like this. Typical. They can be many sizes. They can be up to, I don't know how many micro ducts inside these, but there can be many. So you can imagine they are digged into the ground and connected throughout the city. So you basically blow a cable inside these, and it goes through different kind of junction point where you can split out and branch out the pipes, and then you can blow it around the city. Okay. And this is known as a blown fiber network, and it's very crucial to understand how that works and how, I mean, the complexity in that, because this is one of the weak points of many of the existing DS systems, that they are kind of not good to handle this kind of extra layer of complexity with the blown fiber. Okay. So again, if we go to the DS drawing here. So we have the central office, then we have this kind of black thing that's supposed to be a manhole. You know, the symbology can be different from customer to customer. I just created some symbology myself here to explain it. So the black dot here, that's a manhole, and this will typically contain some conduits, some microducts. So there's no splicing, nothing going on here. Is going on inside the central office, but then they blow the cable into the pipe system onto the different places in the network. So typically they will blow the cable from here to the nearest, to the first flex point, to the next flex point, and so forth. And from a flex point they will blow the cable to something called splice points, and from a splice point they are going to blow some cables to the customers. Okay, so it's very crucial to understand the concept of flex point and splice point in this kind of architecture.
Why they have to blow?
They have to blow the cable because there's the pipe. They dig down the pipe first, right? And then after they have done that, they will blow all the cable through the system.
No, okay.
And also if something happens, someone dig over a pipe or something, they might be able to pull out the old cable and blow a new one. So they blow the cable, you know, when they roll out the different areas. So they don't start by putting cable in the ground. Cables are quite expensive. So they only put the conduit or dot.
No, they blow like Spider-Man.
No, they blow inside the pipe. And there's actually a YouTube video that shows that. I'm going to link to that. Okay? How they do it.
Okay.
And it's a technique used where you don't use poles. But of course you have to have a very good overview of all your pipes and how they're connected to each other. So this is really important, otherwise you don't know when you start here where is it going. And that's one of the challenges we have to solve to make it easy for them to know how things are connected. Okay. So we go back to this one, this guy here, the central office manhole. So as an example, they will blow a cable through here, going up here in one of the micro ducts, and it will be connected up here, and then it will be branched out and go to a flex point. Okay. So flex point is a place where you will split out the signal using splitters. That's what we call a flex point. The flex point can be a cabinet out in the street like this, and you will typically have a well where the pipes go into. Then you will blow the cable, and it will come out of a pipe here. And then you put the cable up here, and back and blow it again to the next flex point. And you do what you call a breakout, right? And this is typically done like this in the residential area, like where we live, you know. They'll have some cabinet like this. And this cabinet can serve quite a big area actually. The other way they do flex point is inside big buildings. So take this one here. So you see, we call these big buildings for multi-dwelling unit or MDUs. The small buildings with only one family we call SDUs, single dwelling unit. Okay. Multi-dwelling units, like a big skyscraper or condominium or business building. What you typically do, if it's very big, is you put the flex point inside the building. So you'll blow cable inside here, inside this cabinet, and inside this cabinet you will put some splitters. Actually the splitters up here is difficult to see, but there's a lot of splitters up here, like this guy. And this guy works that you have one input cable and it's 32 output cables. So it splits the signal to up to 32 customers. So you will put the cable in here, splice it to the patch panel. Actually, you splice it to the feeder end of the patch panel. You connect the splitters. Actually, maybe they have, I don't know, 20 splitters here. And then you connect the pigtails from the splitters. This is called pigtails to the patch panel, which you have spliced up and connected to each condominium. Maybe using a loose tube cables or whatever they're using. So this is kind of the two main way they do flex point, right? Outside in the streets, they can do the flex point, or inside the buildings, they can do the flex point. You can get all kind of different enclosures where you can put splitters in. Some very small one where you only have one splitter, and some very, very big one where you can have connect maybe 1,000 customers. So it's they come in various sizes, but the principles are the same. So, and we call them flex point because it's the flexibility happening here because you patch up the customer. Okay. From there, from the flex point, we're going to connect the flex point out to the city, to the actually what we call splice point. So you see this example here, there's a flex point. This flex point will be connected to a splice point. I have tried to write it like this, so you can see inside the splice point. And this splice point, you will, when you have to connect the customer, this process is very, very important in solution because this is where we gonna optimize, because this is the process they're doing a lot. They have rolled out the fiber net in most areas, so it's the customer connection process that's really important. And typically what they have done is they have put something called a flatliner inside the street. So you can imagine some people living in the street here, some house, and they, in the middle of the street, not in the middle, in one of the sides of the street they have put like a flatliner. Looks like this. It's just a name for some small microducts that are connected together like this. And the reason they love these is because they're very easy to dig down, and they don't, if the heat is changing a lot, they will not, I mean, they're very popular, this type of pipes. If you take this one here, which is kind of old-fashioned type of pipes, there can be more problems with these because the pipes inside this can, you know, bend and screw around when the heat is changing or something, you can imagine. And then they have problem blowing the fiber. So actually this one is used more and more.
So they change from round shape into the flat shape instead?
Yeah, they become very popular because another really nice thing about these is you can just cut out one of the pipes and connect it to another pipe and put it into a house. You don't need very advanced junctions. Like this one is very advanced, right? Because you have to have this kind of enclosure. You cut off the outer duct, you split it up and begin to connect it here. This is very expensive and difficult to create like this. With these, it's very easy. You just take a knife, cut it out, put a little junction on and can connect to the customers. That's why they're very popular in the customer area. And what they do when they put these flatliner in the road, they make sure there's one pipe for each building. So even that, this guy over here, he didn't want internet, but the day he wants, there will be a pipe for him, reserved. you could say. So so what you're gonna do is dig into his house, go into the road, and then you will dig down and get the pipe connected into his house. Then you go to this place, the splice point, and you blow the fiber all the way to the house, right? So you don't have to dig up the street. You only have to dig into the house. Some customers, they already have created a pipe to him and it's just lying in the ground. Some, they don't do any pipes, but connect the pipes when the customer wants internet.
They can customize themselves what they want.
Yeah, depending on the strategy you're using. But almost all customers put pipes, when they dig up the road, it's a good idea to put the pipes in. Oh, what's he doing? So, okay. So this is very important. And there's a very, very good video from plast that shows how this process is working. So you get an idea of this. And the reason I show you all this stuff is because a lot of the struggles with the current system is when the technician has to do this and do it right and choose the right pipe and so on. It can be quite a complex process with the existing systems because they don't get the information they need. And sometimes it can be really difficult, like someone in the office has to create some kind of PDF file, they have to put it in the work management systems and so forth and so forth. We should create a user interface that's very easy for them to do that job here, directly from the field, maybe using their laptop. They always have a laptop with them, or tablet or something. So, yeah, I think this was a little fast, but if you see up here, maybe I can take this one again. So we have the central office with the pipe system going to the flex points, so that they will blow a lot of cable, the big cables to the flex points. From here, they will spread out the signal and have some cables going to each splice point. So this flex point here cover all these splice points. All right. So one central office can maybe be connected to 50 flex points, and a flex point can maybe be connected to, I don't know, 10, 20 more splice points. And each splice point is connected to like some streets with the customer. Typical splice point is like, I don't know, is it 50 customer or maybe more, I don't know. But not 50 customer, but 50 houses. Because you can then put a cable into a house and then you can do something inside the house too, you know, like put splitters in there. So this is to get an overview of how the network works, and then we were gonna dive into later. I mean, what's necessary when you look at from a central office perspective? What is the information they want to be able to see and change and so forth? When they work with the flex points, what is the kind of information they want? It's very crucial because these processes they use today, they always either work here or maybe work here, depending on what job they do, right? So, as an example, if a customer has to be connected, like this guy, he wants fiber. There's basically three processes going on. First, there has to be a pipe connected to him. It can be one team who do that, like a digging team. So to make sure that he is connected to the right pipe, so the system has to provide this team with the information what pipe he has to be connected to, right? In the ground, which one of these? The second process is that some guy has to go to the splice point and blow the cable into the customer, right? And the third thing to be done is that he has to splice the cable at the customer equipment. The customer equipment, that's this one, right? The ONT or the CPE. And he's gonna connect it to the splice closure in the splice point. And then he has to go up to the flex point and connect the customer to the splitter. And then the customer is ready to. Then the customer will have his stuff, and you can provision him, and he get his services, right? So this is a basic process of connecting a customer. And of course, there's also other processes we must support, like if something happens to this line, someone dig over something and they have to make some changes or repair something, they have to be able to see how everything is connected, right? So I think that's, I hope that's give you a little overview of what kind of functionality we have to focus on. Yeah. Do we have any curiosity? Do you know how FiberNet works now?
Yes.
For sure? Okay. That's good. Okay.